Okay. We got what we got. So the camera is now moved back one row. So the audience can hear the students asking questions, and hopefully that will work better. And you'll be able to see more of the screen too, so I don't have to move around. That also means if you're telling butt jokes, then the camera's going to hear it. It's going to be on YouTube. So don't tell any butt jokes.
You're gonna get demonetized.
Got him.
It's already demonetized.
Whoa.
It's an educational channel.
You can't
Like and subscribe. Leave your comments down below.
give us money.
Yeah. All right. So projectiles. So projectiles are the study of anything that is launched, thrown, shot, basically anything that acts in multiple directions. So things go up, things go down, and gravity says, "Oh, I see you go up and down." So when I throw this ball, I'm going to throw this ball to Corey. So when I throw this ball, gravity sees it only doing one thing. What does gravity seeing the ball do? Go up and then come down. Gravity has no idea what's going on in the x direction, because things in the x direction and things in the y direction are independent. Motion in the y direction and motion in the x direction are independent of each other. Okay. Does this make sense?
Yeah.
So that's what the study of projectiles are all about. The study of projectiles are basically saying, all right, let's look at things that are no longer just in the y direction or just in the x direction, and let's see if we can figure out what's going on in both directions. The investigation is very important when you have, understanding vectors is very important in projectiles. So what kind of motion do they follow? They follow parabolas. Why do they follow parabolas? Why is the motion of projectile without air resistance a parabola?
Gravity action.
Gravity and initial force.
Has to do with gravity. What specifically about gravity makes the motion of a projectile a parabola?
It's negative 10 meters per second squared.
Exactly. So we know that objects that are in free fall are falling a distance equal to negative 1/2 at squared. It is that squared displacement in the y direction that makes the motion a parabola. And the reason it's a parabola is dy is traveling squared, but dx is not. How much acceleration is traveling, if you ignore air resistance, how much acceleration is there in the x direction? How much acceleration is in the x direction? How much? 0, exactly. There's 0 acceleration. So since there's 0 acceleration, we can say that, I really gotta stop using green. So since there's 0 acceleration, we can say that the displacement in the x direction is equal to dx is equal to vx times t, where dy is equal to 1/2 at squared. And if you have an initial velocity, and you usually will, then you put in your v0 t plus 1/2 at squared. So those are the two projectile formulas. And they work independently. They work at the same time. So these times are exactly the same time. This time, and this time, and this time are the same time. But the equations work independently of each other. Okay. I talked really fast. Give me a thumbs up if you're with me so far. Wave your hand around if you want to talk about it some more. This is for Bowden, you know. We gotta make sure Bowden knows what he's doing. Yeah?
Okay, wait, I guess quick question.
Sure.
What do you mean when you say y squared for x?
The time component of displacement in the y direction is squared. So basically what you have in the y direction is something equivalent to y equals x squared, which you know is a parabola. So again, that component of displacement makes the y component squared, so it looks like a parabola. I was going to leave my pointer in the same place every time. I was just missing. Okay, well, get the ball rolling. Where's my pointer? Hello, pointer.
It's behind. It's underneath the box.
is underneath the white. Oh, thank you. Always leave things in the same place. As Mommy always said. Put it back. All right. So projectile motion. If you look at just the x direction, then the x direction appears to have linear motion. That is just constant velocity. But the y direction has linear motion that is in free fall. And when you map the two things together, you get half a parabola. So this is something like if you just threw a ball off a cliff, in the horizontal direction, it's going to move with a constant velocity. In the vertical direction, it's going to move with free fall, and its resulting path is going to be a parabola.
Oh, so like when you said it requires vectors, if you think about it as like, you know, so the arrow going, like, say you just go straight ahead, the arrow going straight ahead is that it's a set length, but the gravity one keeps on increasing. So
Exactly.
eventually you'll get to the point where it's just falling straight down and it continues to fall.
It's going to be huge, yeah, exactly. And that's exactly what's you're going to be doing in a simulation. The simulation will ask you to draw the vectors, draw the horizontal velocity vector, the vertical velocity vector, and the resultant velocity vector. So the horizontal velocity vector is going to be the same length at every point in time. And the vertical velocity vector is going to get bigger as it travels down.
And then since it's getting bigger, will it just hit a point where it's just going straight down instead of traveling?
No, if it's still in the air, it'll always have a horizontal velocity.
Okay.
There is no point at which it says, hey, I didn't realize you were going so fast, then we just ignore one component. So the horizontal velocity will always be there.
Okay.
And then the velocity component for the resultant will always be the hypotenuse of the two vectors. Make sense? The velocity vector at every point in time will always be the c squared of the a squared and the b squared. Cool? Give me a thumbs up if that makes sense. All right, so if you like things written down, vertical motion is simple free fall. AY is negative, wait, 10. One of these days I'm going to fix this. Actually, no, I'm not. I'm just going to make it negative 10. Just say negative 10, leave it negative 9.8. Because other teachers use this PowerPoint, and I don't want them to come back and say, well, actually, acceleration is negative 9.8, not 10, Mr. Bars. So anyway, so again, it's just free fall. Are you back?
Yeah, my login is.
Hooray for computer glitches. Okay. And then horizontal motion has constant velocity. So since AX is 0, VX is just constant. It's whatever V naught was. So AX is constant, or say AX is 0, so VX is whatever V naught was. Whatever we gave initial velocity, that's what it stays. Okay. How are we doing so far? We're getting there? Okay. You just want to let's get to the actual investigations of the gravity, and then I can mention that. Which we will. If not today, then tomorrow. Okay. Give me a thumbs up if you're ready to move on. Wave your hand in the air if you want to talk about it some more. All right. So, projectile motion. Projectiles have x motion and y motion. So we have an x vector and a y vector. And this is the point where we would draw the vectors in. So if we drew the x vector, then it would be the same length at every point in time. And the y vector would be larger at every point in time. Get bigger, bigger, bigger. So if you like formulas, here's again another formula. This is basically saying the exact same thing the last slide did, just in a different way. So, now I'm going to prepare something, which I just love. And it's something that my mentor created and I cloned because he's awesome. And unfortunately, I forgot to set up before this.
Hey, full send or no send, baby.
That's what I'm talking about.
Let's go.
This is my student whacking stick.
Oh my.
Yes.
Sounds like fun.
Oh, so he was.
My whacking stick. It's got a nice heavy bonk thing on the end, so I can bonk the students from up front. If you're in the back, you're okay. You're safe, unless you're on the sides. And what I'm going to do is I'm going to attach this. Aiden, could you turn the camera around a little bit so camera can see it? So we'll load this here now, but some people might want to review it later. I'm just going to attach this right here.
Dude, we about to see some wizardry, that's all I know.
Do not trifle in the affairs of wizards,
Exactly.
for they are mysterious and are quick to anger. Turn you into toads and such.
Nah, that's not weird.
Okay. Do not trifle in the affairs of cats, for they are mysterious and will pee on your computer.
Oh, that's a fact, yeah.
That was from Dave Ferry.
Or we'll take the L and the F off of the board.
Couple quarters. All right, so I got two Alaska quarters. They have bears on them.
That's cool.
Yeah, they're pretty cool. Grizzly bears. The reason I have them is when I started this, I was teaching at a school where its mascot was a bear. And this is what I'm gonna do. I'm gonna put the quarters on either end. I'll put them bear side up, either end of this. And then I'm going to bring this back like this and let it go. Boing! And what's gonna happen is one quarter is gonna go zing! And the other quarter is gonna go phew. As the floor falls out from under it, one's just gonna drop. And one's gonna get launched horizontally. Only horizontally. My question for you is this. Am I gonna hear, or am I gonna hear clink clink, or am I gonna hear clink?
Clean.
Who thinks I'm gonna hear clink clink? 1, 2. Who thinks I'm gonna hear clink? Okay. All right.
I have a feeling it's going to be clean when I think about it. That sounded pretty close to me.
We'll do it again.
That's actually pretty cool.
Well, that one, it didn't really fall off when you did it. It kind of got swung backwards. There you go.
That thing went. I'm not even sure I can find that one. That thing really. Oh wait, it turned into a penny. Oh, here it is.
When you shoot it so fast.
It turned into a chemistry penny. So, did you hear clink clink, or did you hear clink?
I heard a thing.
Yeah, it's clink, right? We just heard clink. So, even though this one got launched, it was falling at the same rate as this one.
Yeah.
Right? It's not like gravity said, oh, I didn't realize you were going horizontally. Continue on. Does that make sense? So we don't hear clink clink, we hear clink because they fall at the same rate. One goes out and one goes down and they go clink together. So my question for you is this. And this might require a little math. If I went out to the Mojave Desert, made sure there was nothing in front of me for miles and miles, and I took a rifle and I put it on a stand, my little rifle, I put it on a stand exactly 2 meters high, and I made sure I had a little bubble level. You know what a bubble level is? Make sure things are level. So I had a little bubble level, so I made sure this was exactly 2 meters at 0 degrees. It's gonna fire straight out. And I pull the trigger. Boom! The rifle bullet, which is traveling probably 3 or 4 times the speed of sound. If I launch that thing out at 3 or 4 times the speed of sound, horizontally at exactly 2 meters high, how long does it take for the bullet to hit the ground?
I'd say around 6 meters.
So you can figure that out. I'm gonna fire that horizontally out in the middle of nowhere, out in the desert, perfectly flat. It's like total, I can see the horizon. 2 meters high, boom. How long does it take to hit the ground?
Oh, shoot.
32 seconds.
32 seconds.
That's a long.
It is possible to type too much.
That's at least like 2,000 yards.
What's the free fall? So, point.
What?
So it just goes, oh, trying to have it still.
I can grab it. there's a thing you have to like plug it into.
But it's supposed to help, right? Yes, I'm
All right. Who got a time larger than 1 second?
Wait.
Oh, wait. Okay. Sorry, you're still doing math?
Yeah.
All right.
Larger than what?
1 second. Nah. Who got a time less than 1 second? Okay, so what did you do? You said, oh, it's in free fall. And how far is it free falling?
2 meters.
2 meters. And 2 meters is equal to 1/2 times the acceleration. What do we use for gravity?
-10.
-10. But it's going really fast. It's going really fast. Should we still use
Gravity don't
-10?
care how fast you're going.
Yes,
It's still
exactly.
gonna drop.
Gravity does not care how fast you're going. Because as far as gravity is concerned, the bolt's just doing that. It's just doing that. So even though we know it has a huge horizontal velocity, gravity doesn't know that, nor does gravity care about that. So then we just solve for t squared. And that is the square root of 5. Is that right?
0.2.
Sorry, no, square root of 0.5. Anyway, so what is it?
It was 0.63.
0.63? 0.63 seconds. Okay. Or
Wait.
something, anyway, whatever that happened to be. So, does that make sense? So, gravity does not care how fast it's traveling in the horizontal direction. All it cares about is that bullet is falling 2 meters. We know that's all we care about. Does that make sense? Yeah. Kind of goofy, but it works. Okay. Questions? Yes.
Okay, so it would normally just be d equals 1 out of h squared, but you did the vertical, you did the height of it, dy, realized it was 7d.
Yeah, because that's free fall.
Yeah, because it's falling for 2 meters, so I just said dy equals,
Okay.
and we're going to be using subscript y's and subscript x's from here on out. So since now we are talking about two-dimensional motion, we're going to use dy and dx from here on out. So if we're talking about, and vy and vx too. Okay, cool? A we're just going to say is a, because there is not going to be any ax. Yeah.
So dy is still technically the same as like d. It's kind of like the y and fx situation. Like they're the same thing. They're interchangeable. It's just a different way to write it.
Yes, we're saying displacement specifically in the vertical direction.
Okay.
And we're going to say velocity specifically in the vertical direction and velocity specifically in the horizontal direction.
Okay. That makes sense.
Okay. Other questions? All right. Yeah. Okay. So moving right along, this is what we care about, right? We care about ground launch projectiles. So potato goes up, potato comes down.
Yes, then.
Oh no. Headshot.
Ooh, headshot. I love this GIF. I especially love that for some reason
They fall.
PowerPoint slowed it down.
He's like with these lots of person walking by.
He just takes the guy out too. It's like, man,
That's scary.
That ball
he's like, baller.
I don't know if the ball's actually that
Bam. I know, but I think this is the shock of the thing. Anyway, so yay, Walmart. Okay, they're rolling back old people.
Oh, I've been
Suppose an artillery shell fires a shell from the ground with a velocity vi and an angle of theta. These are all things we can find out. Hello. Oh yes, the coin thing that we have seen again. Look, this is the coin thing. You could put coins in it. I'll put it right here. You know what I should do is I should charge people a quarter every time they go to the potty.
Oh my.
I'd make $1,000 for charity. Okay, so these are all things we can figure out. So what we're going to do is we're going to simulate or calculate what would happen if a cannon. Oh, cannons. Okay, how do I draw a cannon so it doesn't
Draw
look
like a
penis?
circle for wind.
Okay, like that.
There you go. Yeah, perfect.
Still kind of looks like a penis, but anyway.
Oh,
Cannons,
you
cannons are hard to draw without making them look like a penis. So there we go. So
Human anatomy.
Yeah, dude. I don't know.
Sorry, we're trying to keep you monetized.
Is this is this anatomy or physics?
it's all those things. All right. So what I need from you is this: the velocity the projectile leaves the barrel is going to be vi, initial velocity. So and we're going to have time 0 and velocity vi. How fast is the projectile leaving the barrel? You can throw something out.
30 meters per second.
30 meters per second. So it's leaving the barrel at 30 meters per second.
I know, but it's...
At what angle is the cannon angled? At what angle is the cannon firing?
45 degrees.
We're not doing 45. We're doing 57? So 57 degrees. So it's going up at 57 degrees.
Oh.
We can determine all these things. We can determine the final velocity, the flight time, the maximum range, which is going to be dx, and the maximum height, which is going to be dy in every one of these cases. So, what is the first thing we should do with a two-dimensional vector? What is the first thing we should do with a two-dimensional vector? Because this vector is coming out at an angle. It's got a magnitude of 30 meters per second and an angle of 57 degrees. Magnitude. What should we do? Direction is 57 degrees. What we should really find are the x and y components, exactly. So what we need to do is we need to take this vi and we need to break it into vx and vy. It's not y, vy. So take the vi, the velocity initial, and we need to break it into vx and vy. Because these are things we can work with. We can't work with just a v at an angle, but we can work with a vx and a vy. Cosine and sine. So do that now. If you don't have a calculator, I can throw one at you.
It's like
Anyone else need